In this video, we show what follows the development of claims, evidence, and reasoning by our novices. They will use what they now know to create final versions of their explanatory models.
So we'll talk in a second about what I've got up there at that resource table and what I put on the walls. These are the kinds of things that you bring to the classroom or have out when people are doing a final model. The second thing that I hope you can generalize to the units that you're going to teach is the role of an explanation checklist.
The explanation checklist, or otherwise known as the gotta have checklist, is a set of ideas that must appear in the model and in the written explanation. Note that it is not a list of vocabulary terms. The items on the checklist are often expressed as relationships, as the second and third items on this list are. Students can co-develop this list with you as the unit progresses. In our classroom observations, the checklist has never given away answers to students, but rather has allowed them to focus their modeling and explanation efforts on the most important and rigorous ideas that are associated with the anchoring phenomenon.
The third thing that I want to do today is another experiment, which is I'm going to have you play out some group roles. I tried to make these all intellectual roles, not roles where somebody runs up and get the materials, or somebody is just reporting data, and that's all they're doing. What are you laughing at?
Trash captain.
Trash captain. I forgot about trash captain. Yes. These are all intellectual roles, so the task manager, the job of the task manager is to keep everybody on track, make them aware in the first place of what are we supposed to do? What are the instructions actually telling us to do? Because kids, like adults, can often start engaging in the work and not realizing what the goal of the work actually is. There's another role. Dennis, what's another role?
The idea exchanger.
And what does that person do?
To see what ideas other groups have incorporated into their models and report back to the home group. So they're kind of like the outsourcer, kind of. They go out
The spy.
and source and spy.
Scout is what we, I like scout.
Outsourcer, spy, or scout. One of those three.
Recon manager.
Recon person, yes. I'm going to make an announcement in the middle of this class period, and I'm going to say now is the time when the idea exchanger is going to get up and visit a couple other groups and enact that role, and then go back to your home group and just describe for a couple minutes about what you saw other groups doing that may contribute to your own model. So I have a specific time to enact that role. So what I'm trying to do is use roles, but I'm not leaving it up to kids when to enact a role. I'm doing more scaffolding than normal.
When you I really like the idea of making the announcement to enact roles. I never would have thought of that. Are you going to give them like a time frame? Like, are we going to have like a timer?
Yeah, I would time this. I would just say I want you to visit a group, to spend 3 minutes at each group, listen to what they're saying, look at what they've got. You could ask them a question if you want to, but let's rotate.
Are you going to time this like a rotation?
Probably. Not time it with my watch, but just in general.
I had thought about the idea exchanger would be a great role to use to accommodate someone who is really squirrely or who needs to get up a lot. It'd be kind of good to say, I want you to have this role.
And how would you
Third. What's the third role? Esther, can you read the third role?
Gaps monitor. Purpose is to see what gaps your group might have in the model. Actions after the group is nearing a complete model. Ask the group members if there are any links to manufacturers in the ecosystem that you are unsure about. These can be things that, one, you don't know how they're related, or two, you want to ask the teacher for a chance to get more information on a part of this ecosystem.
Before we get started on our models, I tell my students what resources they have available to them. Authentic modeling is not some kind of memorization test, so I don't tell them, please close your notebooks. Rather, we aim to do what scientists do, create a causal story using all available information and ideas.
So these are the major activities we did. I reproduced our hypothesis checklist. You may not have both of these things up when you do this, maybe just one of the two, but I put both up. So could all these hypotheses actually be right? Which one is the right one? Or are more than one of those actually correct? And maybe you have to think about weaving some of these hypotheses together. Because this is what happens in authentic science. Often multiple hypotheses have some truth to them. And the actual ending explanation involves weaving together two or more, or three or four hypotheses. Task manager, if you can get your people started, do that now.
As my novices complete changes to their models, I can see how far their thinking has advanced about climate change and ecosystems. This thinking is made visible and shareable by the modeling process. If we look at changes between their first and final drawings, we can find evidence that their thinking has changed. In their originals, there are lines that link organisms in simple and unproblematic ways. When energy is shown, it is represented as sunlight being used by phytoplankton, but the energy story ends there. Their final models are far richer in their conceptual content, and they show many more interconnections between biotic and abiotic parts of the ecosystem. Each part of these new models incorporates new ideas that are noteworthy. In this part of the model, we see how our novices understand climate feedback loops and how they affect organisms that form the base of the food chain. In another part of the same model, we see that our novices understand niches and what adeles are adapted to do. For example, to feed in particular ways, to nest in particular conditions, and if those conditions change, the adele is no longer adapted to its environment. In the same model, we see that our novices have taken the idea of a feedback loop and applied it to the complicated feeding relationships between adeles, leopard seals, and krill. In another model, we see that a group has created many more connections than in their original model, and that these links are recursive rather than linear. These novices have unpacked the role of krill as a keystone species. They have represented the role of the chinstrap penguin and how it outcompetes the adele when the climate shifts or when sea ice becomes scarce. This group has created a key because they want to differentiate between climate-related drivers of change and drivers of change related to resource availability. And rather than starting their model's activity with the sun, they begin the story with rising carbon dioxide levels. This third model tells an energy story, for example, about how 10% of available energy at any given trophic level is passed on to the next, and also how foraging out in the open water costs the adele penguin much of its stored energy. In this fourth model, we again see the numerous connections among many elements of the Antarctic ecosystem. The legend this group has created includes several conceptual ideas that were not represented in their original models. For example, the flow of energy again, abiotic factors, competition, and the important scientific category of we need more data here. In this final model, the group has carefully traced how energy is being constantly transformed and transferred throughout the ecosystem. These pathways are represented by the yellow lines. Simply by looking at one corner of their model, we can see how extensive their written explanations would be for the whole anchoring phenomenon. All of the text seen here describes only the initiators of climate change. High school students we have worked with have used their models to produce several pages of explanation, something many teachers would find impressive. If we now reflect on the work our novices have done across this unit, we can identify a whole range of ideas that they have made sense of and integrated into a causal story. We have also seen our novices engage in a number of scientific practices. As these new educators begin to work in their own classrooms, they'll be able to take these experiences, along with the core teaching practices, to start their careers on a solid foundation.